What's up guys, welcome back. So today I wanted to do a basic video on the compound interest formula and compound interest questions and basically how to manipulate the equation to get what you're looking for. Let's get into it. All right, so this question says the future value when $50,000 is invested for 7 years at 3.5% per annum compounded annually. So we want to find the future value when we invest 50 grand for 7 years at 3.5%. So for starters, this is the compound interest formula. Future value equals present value 1 plus rate to the power of n. And future value is basically, like it says, what you're going to get in the future after your investment, and present value is what the money is now, or what it's worth now. And R is your rate, and N is the number of periods. Okay, so for this question, all we need to do is literally just substitute it in. We got 1 plus the rate, which is 3.5% per annum. So make sure per annum and years are the same units. That way we don't have to actually change anything. So 0.035 as a decimal to the power of 7. And that's our answer there. So just pop that in the calculator. So 50 grand, 1 plus 0.035 to the power of, whoa, to the power of 7. So the future value is worth 63,613.96. Okay, first one done. Okay, let's look at this next question. It says Aiden and Zoe plan to save $50,000 in an investment account in 10 years for their daughter's wedding. The interest rate for the investment account is fixed at 2.5% compounded monthly. How much will they need to deposit in the account today to reach their savings goal? All right, so a fair bit of information here. I'm just going to highlight some important bits. So they're trying to save $50,000 for 10 years. They're also doing so at a rate of 2.5% compounded monthly. So how much will they need to deposit now? So how much will they need to deposit in the account today? So that tells me that this is present value. So that's what we're trying to find. We're trying to find the present value. So this must be the future value. This must be N, and obviously R is your rate. So first of all, I'll write out the formula. FV equals PV 1 plus R to the power of N. Okay, so I'm looking for PV. So that means I need to get all the other stuff, so all of that stuff, to the other side. So I do so by dividing both sides, and basically what that looks like is just putting it all over FV to make PV the subject, okay? All right, now all we need to do is substitute the numbers. So PV equals future value, which is 50,000 over the rate 1 plus. Now here's the little thing you need to watch out for. Because it's compounded monthly, I need to divide the rate by 12 for 12 months. So 0.025, because 2.5% as a decimal, divide by 12. And all of this will be to the power of 10 times 12. So however many months there are in 12. So however many months there are in 10 years. Now, I would recommend you just to put all that in the calculator in one go, so that way you won't miss anything. All right, here we go. So 50,000 over bracket 1 plus fraction, so 0.025 over 12 to the power of 10 times 12. So the present value here is going to be $38,950.17. So in other words, they need to invest this now for 10 years at 2.5% compounded monthly in order to have $50,000 in 10 years time. All right, cool. Okay, let's look at the next one. It says $25,000 is invested for 5 years and it grew to a future value of $31,250. If the interest was compounded annually, what was the interest rate per annum? So straight away, you can tell we're looking for R. That's the missing value. It's compounded annually, and we know that it's 5 years. I also know that 25,000 grew to a future value. So it's telling me that's the future value, that's the present value, and that's N. All right, so A little bit more complicated, but we'll still be able to do it. Start with a formula, 1 plus r to the power of n. Now this one I'll do a little bit differently. I'm going to substitute the numbers first, just to avoid the algebra in case you're not that strong at it. So the future value is 31,250. I'm missing the present value, aren't I? So PV should be there. Present value is 25,000. 1 plus, now I don't know what the rate is, so I'll leave it there. And n is to the power of 5. Okay, so I need to somehow get r by itself. And what I'm going to do is I'm slowly going to kind of unwrap this part to get to the r. And my first step in doing that is removing or getting rid of the 25,000. So I move it to the other side, 31250 over 25,000. 1 plus r to the power of 5. All right, cool. The next bit is I need to get rid of this 5, okay? Maybe use a different color here. So I need to get rid of this 5. Now I do so by basically doing the 5th root. So it's kind of like the square root when you undo a square. I do this little symbol to get rid of that 5. And all I'm left with here is 1 plus r. And I can kind of get rid of the brackets here. All right, I'm almost there. So I need to just get r by itself. So I need to subtract the 1. So rewriting this, minus 1 equals r. And that will be my answer. So just popping that in the calculator. So normally your calculator will be shift square root button. Actually, I lied. But it's okay, I can just change it here. So that is going to be 5 inside the bracket. Oh, sorry, inside the root will be 31250 over 25,000. And I'm going to take away 1. So my answer, r is 0.0456 times 100 to get a percentage. So r is equal to 4.56%. Okay, so that's an example where you need to find the r, or find the rate. All right, cool, last one here. So Natalie inherited $150,000 from her grandparents. She decides to invest the inheritance in a bond yielding 4.8% per annum compounded quarterly. How many years will it take for Natalie's investment to triple in value? All right, so once again, let's just see what we got here. So she inherited $150,000 and she wants to invest it at 4.8% compounded quarterly. How many years will it take for the investment to triple? All right, so straight away I know I'm looking for n, because it's how many years. And for this investment to triple, well, it's going to be 3 times 150,000, isn't it? To triple in value. So I need that to be 3 times 150,000 is 450,000. This will be the future value, and this is the present value. Okay? So let's put it in the formula, writing out again, FV equals present value 1 plus r to the power of n. My future value here is 450,000 is equal to my present value of 150,000. 1 plus 0.048, so it's 4.8% as a decimal. But since it's compounded quarterly, I need to divide by 4. Okay, so all over 4 to the power of n. Okay, so I'm going to start with that there. Now, first thing is there is a way to find n used mathematically, and we're just using logs and stuff like that. But for the purpose of standard maths or standard 2 maths, you just need to apply guess and check. So what's the best way to do that? So what I'm going to do is I'm going to put all this in the calculator, and I'm basically just going to try different numbers for n up until when I get to the point of 450,000. So 150,000, 1 plus 0.048 over 4 to the power of, and now I'm just going to try it. So let's try 5. So 5 gives me 159,000, so pretty far off. So let's do 15. So still very far off. So maybe let's go big. Let's go 60. Okay, so now we're at 300,000. So still bigger. Let's go 90. We're getting close, so it's 438,000. Let's try 99. So 488, so we've got to go a bit lower. Let's go let's go 96. Closer still, 95, 94, 93. So I think that's it. 93 is going to be my number. 93 is going to get me to... Oh, no, it won't. That's 454,000. Oh, yeah, it will. So 93 is going to get me to 454,000, which is more than 450,000. So I say, therefore, my N is approximately 93. Now, what does this 93 represent? This is 93 quarters because it's compounded quarterly. So if I want this in years, I just divide by 4. So 93 divided by 4. So 23.25 years. Okay, so once again, there is a method to get the precise number, but for the sake of standard 2 HSC maths, all you need to do is guess and check. All right, I hope that video helped. If you liked it, let me know in the comments. If there's any other videos you want to see, let me know. Otherwise, I'll see you at the next one.